which asks how many critical points does the function have? And a critical point is where the derivative equals 0. So it doesn't matter what we choose, we're going to have to take a derivative to determine that. If you think your quiz will be like this, I can give you something like this. I can also make something similar, like or change it up.
Yeah, it's going to be in this exact format that this worksheet is on. I don't know if it's going to be the same like problems. It's not going to be the same ones, obviously, but the same type of problems. I don't know.
All right, let's just make them slightly smaller here. So let's just say this is your original function. And this is why you've got to be so good at taking derivatives now. It's no longer like just about taking derivatives, it's about taking the derivative and then using it. So the derivative here is product rule. And then it's got elements of chain rule in it. So do you like to take the derivative of the first? I can't remember.
I keep the first derivative.
Okay. Keep the first. Derivative of the second is 2 times x plus 2 to the power of 1. And then the derivative of the inside function is 1.
Oh, you have to do that. Okay.
That's the chain rule part of it. Plus, okay, take the derivative of the first. Derivative of the inside is 1. And the keep the second as is. So it looks really bad. I mean, it looks like how do I set this equal to 0?
So where did you get the x plus 2? Isn't it x minus 2?
I changed this.
Oh, wait.
I'm sorry.
Oh, sorry, I was okay.
I'm sorry. I changed this to something that's basically the same, but just less exponents. Okay. Let me know when you get caught up to this line for us.
Yeah. That's good.
Okay, so rather than rewriting here, because rewriting takes a lot of time, is you want to factor. So like you look for like what's common in both. So there's an x minus 1 squared in both. And there's an x plus 2 in both. Okay, and then you like figure out what's left over. So from this first one, there's an x minus 3 still. I'm sorry, an x minus 1, and then a 2. And from this next one, there's a 3 and an x plus 2.
Right. Okay.
And
all equal to 0.
All equal to 0. So now this is like not calculus anymore. You set each of these equal to 0. X minus 1 squared equal to 0. X plus 2 equal to 0. And then this middle part equal to 0. Now this is where you gotta also remember what the question is asking for. It's not asking what. It's asking how many. And there's one from this. There's one from this. And there's one from this. Now you may still feel like you have to actually solve each of these to like verify that, but like there's an element of this AP that's like the SAT, ACT, where it's more like you don't actually have to do it. You just have to know what the outcome is.
Okay. So just okay.
Is that acceptable to you?
Yeah, that makes sense.
Okay. All right, so there's 3. I guess we could say 3 total. Okay, move on to number 2.
Yes.
Okay, for what value of x does the function have a relative maximum? So we're not going to do this because I guess you've already done this, I think, although I don't see any. Maybe
yeah, I cut off.
Oh, you did. Okay. So whether it's asking for relative max, relative min, again, you have to take the derivative. You have to take the derivative. You have to set it equal to 0, and you have to do some sort of like sign analysis on that, like positive, negative stuff. So do you want us to do this one or one like it?
One like it, maybe.
Okay, so f of x equals x minus 2 squared times x. I'll go plus 3. That should be okay. All right. Anyway, take a derivative.
Okay,
So
so
you got
the x minus 2 squared times
derivative of this.
that
Is just
1,
one. Yep.
and then times, you have to do the, oh, I see.
Keep the second, and then it's
What about
2.
the chain rule part?
We did that already. So keep the first,
Uh-huh,
and then derivative of x plus 3 is 1.
okay.
There's no power here.
And then x plus 2
Yeah.
times 2, yeah, okay.
Okay. And then, and again, like you factor here, like you are setting it equal to 0, but you need to factor.
Okay, so you can take out an x minus 2.
Yep. And that leaves you with x minus 2 plus 2 times x plus 3.
Mm-hmm.
And you set these both equal to 0, or set this equal to 0. So this time you actually do have to solve them.
So x equals 2. And this one also equals.
So this ends up being 3x plus 4 equals 0.
3x x 4, yeah, negative 4/3.
Okay, so this is the following is my preference, and it is allowed, is you make a number line on the derivative, and you make a mark for each of the
Yeah, that's what we do in class. That's what he
okay,
likes.
great. And then the next part here is you have to choose test values. So like they have to be in between here. So these are arbitrary, but you know, just pick something you feel comfortable you'll be able to do. So
And
we
then
actually have
you plug it into the derivative or the original.
the derivative. Okay.
Okay.
And this part's a little bit hard to kind of to explain, but let me just do this here for a moment. This inside here we just showed reduced to 3x plus 4. That was this line right here. So this is the derivative simplified. X minus 2 times 3x plus 4.
Okay.
Now you don't need the value. Like you don't actually need the number. You just need to know whether it's positive or negative. So like when you test 5, you want to think 5 minus 2 is positive, not 5 minus 2 is 3. And then 3 times 5 plus 4 is positive, not 19. Because it's a positive times a positive.
Okay.
And the reason is because you only care whether it's positive or negative. It's positive in that window.
All right.
So now you try 0.
So 0.
That's negative. 0 minus 2 is negative. 3 times 0 plus 4 is positive. Negative times a positive is
negative.
negative. Was that emphasized in class or not?
What?
This whole idea of like whether it's positive or negative.
Yeah,
like,
yeah. Increasing,
okay.
decreasing.
But like you don't need the number, because sometimes like students think they really need the number here, and
No,
you don't. Okay.
That's what we did. We just
Okay.
negative and then
Okay. So now negative 2. This is negative.
probably
This,
gonna be positive.
this is negative. Yeah. Now it is a mistake to think that they always alternate.
Yeah, that's what he was
Okay.
like. It usually does, but don't just guess.
Yeah, it's a huge potential. It's like it's the 80% of the time it will alternate, but you don't know. Okay, so now what's maybe unclear is that plus to minus is a max. Okay, and minus to plus is a min. These are now like summary rules. Plus to plus is nothing. It's actually it's still a horizontal tangent, but it's nothing in terms of mins or maxes. And minus to minus is the same thing.
Well, it's ours is plus minus plus, right?
Yeah. So like you can remember
what we did is like I like drawing the lines like almost so that I can like see,
Yeah.
like,
so that's what I was about to do. I was going to show you that if increasing means this,
right,
and decreasing means that. So that's a min, and that's
so our
a
min
max.
is at 2 and our max
Right,
is
right.
okay.
Okay, so now like we just did a lot of stuff we didn't necessarily need to do. And I don't know if you're usually styled this way, but it's just asking for the X value. Meaning like you don't have to give the Y. So like we are done.
We didn't find the Y, did we?
No, but sometimes they want to know not only what is the X value, but they want to know what is the relative max or what is the relative min, not where does it occur.
I see.
So you have to be comfortable doing both.
Okay.
All right. Is that clear?
Yeah.
Okay. The stuff I wrote here, I mean, this is like your summary note card stuff, if you need it.
Okay.
Right. So if G is a differentiable function such that G of X is less than 0 for all real numbers. So what that means is it's always negative. I mean, that's what that's trying to say there. They give you the derivative, okay, and they're asking like which of the following is true. Maybe we should just go through this one as is rather than try to do that. So this time, what's interesting is they give you the derivative. You don't have to take a derivative. So just be aware of that. Like you might get a problem where this is already done for you. You don't need to take a derivative again. So you want to set it equal to 0. Okay, so you might be thinking, well, how can I do that, Matthew? Like it's G of X. Well, G of X is always less than 0. So it's never equal to 0. So you're really just looking at this first part, x squared minus 9. Where does that equal 0? And two values like plus or minus
3. Yeah.
Yes. So you build your number line again, f prime of x, and you put those two critical values on the -3 and 3, and you test points again. So like 0, 5, and -5. Okay. So sorry. So you go back to this right here. So let's try 5. 5 squared minus 9 is positive. G of 5 is always negative, according to this over here on the left. So it's a positive times a negative, and that gives you a negative in here. Is that okay?
Yes.
Okay. So the next one is 0. 0 squared minus 9 is negative. G of X is always negative, according to this over here. So a negative times a negative is a positive. And then similarly over here, when you try -5, you get a positive times a negative gives you a negative. Okay. So rather than like going through all of the answers, like let's talk about like what's going on here. And you mentioned this in the previous example. The original function is decreasing here and here. And then it's increasing in here. So is -3 a min or a max?
It is a min.
It is. And maybe you're drawing something like that.
Yeah,
that
I'm trying to draw it in my head.
Yes. I mean, use your, on your exam, use your finger, draw it with a pencil, whatever you need. I mean, like make sure you got it down. Increasing
our max
is a max. Yeah. Okay. So the critical points are x equals -3 and 3, max or min at x equals -3, max at, these are relative, at x equals 3. And that's kind of all you can say from this. You could also say like it's decreasing on the interval -∞ to -3, comma 3 to infinity, only increasing from -3 to 3.
Mm-hmm.
And then you just choose the one that matches up to that.
Oh, okay.
Now I know we didn't change the numbers in this one, but like we could do one like it right now if you would like, where I change the numbers. Would you like to do that, or would you like us to move on to another question?
can move on. It's fine.
Okay. All right, number 4. This one would be harder to make up, but this is a really good question. This is your classic question where you got to figure out, relative min, relative max, absolute min, absolute max, some other stuff too. Looks like you got to find oh, this is free response. I see.
Yeah.
All right. You already did this one though, right, in class?
Yeah.
All right, so let me change it up slightly.
And he also said that the quiz is going to be no calculator, so he wouldn't include like LNs.
Really?
Yeah.
Okay. Maybe we shouldn't do this one then. I mean, there's other ones we should do like this, but
Like
maybe not.
when you get the like final points, you have to like calculate to find the absolute max. You know what I mean?
Right. It's just it'd be like the natural log of 3 minus 2.
Yeah, it was like 3 ln 6 plus 4, and that was the
Yeah.
absolute max.
Yeah, and I guess that could be an issue. Let me see if I can make one up real quick.
Okay.
That's reasonable. Nope, that ain't gonna work. Yeah. We gotta look at one other thing. Okay, so like this may be you told me this is too difficult to do, but this is like one that another calculus student at another school is working on, and it's kind of the same thing. It's like find the critical points, things like that. I would recommend we just work on stuff you want to work on though, but I don't know that I can find something else like this.
We can do.
Mention some College Board.
Well, what is that one that you put up?
It's just like finding the derivative of this and then finding the critical points would be like the
We can do
first.
that. Let's do that one first,
Okay.
and then go to the College Board stuff.
All right, so here is the original function. To take the derivative, you need product rule and then chain rule. So would you at least attempt to do that on your own
Yes.
for me? Is it okay if I log into your College Board while you're doing that?
Yeah. So E stays the same, right?
It stays the same, yep.
Okay. Okay, is it?
All right, so let's go x squared, and then you keep this.
Yep.
Now this is the hardest one. So it's x to the minus 2. So its derivative is minus 2 x to the minus 3, and then you want to rewrite it like this as minus 2 over x cubed.
Is that the chain rule part?
Yes.
So it's the
derivative of e is itself with the same thing, and then you multiply by the derivative of the inside function.
What's the inside? Isn't the
1 over x squared is the inside function.
You don't do the chain rule for the x squared?
It's 1 over x squared, so it's the whole thing.
No, but the first part,
no, because you keep it. You keep that.
Keep, and then
there's plus that. Then you do the derivative of the.
Okay.
So it'll be plus 2x e to the 1 over x squared.
And then what about the chain rule for that part?
It's done. Derivative of x squared is x, 2x. There's no chain rule.
Well, it's just one, right?
Yeah, it's just one. Yes.
Okay. -2. Okay. And then it's minus. Okay, got it. So then you set each, or you have to factor, huh? So you can take the E.
Yeah, so you can factor out an e in both of them, and you can factor
Wow.
out an x and a 2, and actually a -2 from both of them. But actually, I should have, actually, I take that back. I should have had you simplify this first. So it's
Okay.
-2 over x, e to the 1 over x squared, plus 2x, e to the 1 over x squared.
So then you take out your
You take out the e, and then
-2.
but just leave that in. Like, if you're not sure, just leave it in. You're just
Okay.
trying to factor out stuff actually that like doesn't contribute. So like e to the 1 over x squared is never negative, is never 0. E is never 0.
Okay.
So now you set this inside part equal to 0. That's why I wanted to look at this one, because it's got, you know, a little
Wait,
more.
you never set, but why don't you set the E?
E to the x is always greater than 0. So this 1 over x squared doesn't ever make it 0.
So then you set the -2x.
You set all this inside here equal to 0, and you move this term, the minus 2 over x, to the other side. 2x equals 2 over x, and then you notice this is kind of a side point that x cannot equal 0, because then you're dividing by 0.
It's undefined.
Yeah, but then you still keep going. So you multiply both sides by x, and you get 2x squared equals 2. Move the 2 over.
Well, then you have to divide by 2.
Or you can divide by 2. There's lots of ways to do this, and you end up getting x equals plus or minus 1 as your critical points.
Okay.
But this part's important right here. So and it was true in the original. Like if you go back to the original, x cannot equal 0, because you can't divide by 0. 1 over 0 is undefined. So that's really important. So this number line, that's why I wasn't sure if you talked about this in class. It's not only the critical points, it's also the places where the function or its derivative are undefined.
Oh, okay, yeah.
Maybe that's come up in class.
Yeah, I remember him saying that.
Okay, so when you test a value, okay, when you test something here, you test it in.
You test the 1 and the -1.
You have to test points not those places. You want to test like 2. You'd want to test like 2, 1/2, -1/2, always something else. And I draw them kind of down here so that I don't make the mistake of testing a point that I shouldn't, because you'll get 0 or undefined.
Okay.
So when we test
0, so 1 and -1 are our zeros, and then what's 0?
It's undefined.
Okay.
And that's important, because you're gonna, I think you'll see something on this. So let's try 2. We go back to here. This first one's always positive. Okay, so like what's going on inside here? -2 over 2 is -1, plus 2 times 2 is 4. This is positive. So it's a positive times a positive.
So positive.
Positive, yeah. Now it's gonna be a little harder because we're gonna do fractions here, but 1/2 now. -2 over 1/2 is -4. 2 times 1/2 is 1. So this ends up being a negative inside here, times a positive. Negative, yeah. Now let's try -1/2. This becomes a +4 minus 1. So this is positive times a positive is positive. Okay. And then this one over here ends up being, I believe it ends up being negative. Just double check that. Yeah, it does. Okay. So the mistake here is to think that something happens at 0, but 0 is not a critical point. So the fact that it transitions from from positive to negative is irrelevant. Like it doesn't matter. This is like a break in the graph right here.
Okay.
So there's something going on here at -1. It's decreasing to increasing. So this is absolutely a min. Okay, but so is at 1. It's decreasing,
Yeah.
increasing. This is also min, but nothing is happening here because it's not part of the domain.
So there's no max.
No.
Okay.
The examples you showed me don't have any of this behavior, but either that's coming or your constructor's excluding it. But
Okay. That makes sense.
all right, so I got into your College Board here. I see a 5.1 to 5.3 review 2021 or 2020. Do you have a preference on that?
Yeah, I think I started with the 2020. I have to do both by Wednesday, but I think I started with 2020 already.
So would you like us to go there to 2020?
Yeah, I think I've maybe only done the first one.
Okay. All right. Should we go through the first one?
No, I had him help me on that one, so I think I'm fine on the first one.
Okay. All right. So
That was the one with the graph, right?
Yes, they actually look like they're all got some element of a graph in there.
Okay.
So let me grab this one and get it into our workspace here. There it is. Okay, now it's so important to know, like, are you looking at the derivative or are you looking at something else? And like the original function, because it's the derivative, like there's a set of characteristics that matter here. Okay, so what I'm trying to say here, I'm not maybe being too wordy, is that A and C are where f prime of x equals 0.
Okay.
And if you were to convert this to a sign chart here, which is what I would actually have you do, A and C, the derivative is decreasing, increasing because it's positive. I'm sorry, the original function is decreasing. The derivative is negative. The derivative is positive. The derivative is negative. So that means that A, the original function is coming down and then going back up. That's a min. And then at C, it's going up, the original function, and then coming back down.
So C is your max.
Yes, if that is, and these are the which of the following statements true. So you got to look at all of them. But like, it's good to like know those things. And so so it's not C. I'm sorry, it's not A, because the min is at A, and it's not B because the max is at C.
Okay.
Okay, now we go to the other ones. The graph of f has an inflection point. So an inflection point occurs.
So is an inflection point like when the signs change, or?
You have to look at the second derivative. It's when f double prime changes from positive to negative or negative to positive.
How do you know the second derivative? They only give you a graph.
It's a fair question. You're looking for mins or maxes of f prime. So see how there's one right there?
Yeah.
That's your max. So the derivative is increasing and then it's decreasing. So there is an inflection point at B.
But isn't that the graph of f, the first derivative?
Yes. So the rules like you treat f prime of x now like it's f, and like because you're looking for f double prime, you look at the graph and say, well, I'm looking for peaks, mins, and maxes for my critical points of the second derivative.
So so you're just looking for where the.
So because you're given f prime, f double prime is the derivative of f prime. And the things
So
that you're
wouldn't there
looking,
be an inflection point at A and C then?
so A is where the derivative is equal to 0.
Yeah.
The second derivative is only equal to 0 where the derivative has a horizontal tangent.
Oh,
It's like a progression of rules
well, but
that
why does it say inflection point when changes from positive to negative? It's
it's increasing to decrease,
so then, so is it,
that means increasing to decreasing. Sorry, that's not the right, that shouldn't be that.
right, so is it that or is it equal to 0? It's both?
No, the inflection point occurs when at a min or a max of f prime. Let's just keep it like that, because that's much clearer. It's wherever there's a min or a max of f prime,
Okay,
and we have one right there at the top at B.
because we don't have a minimum.
And there is none. Yeah, it's because the f double prime sign chart at B, like this is increasing, so this is positive, and this is negative for the sign chart of f double
Hmm.
prime. See how the derivative is increasing here and then the derivative is decreasing there?
Yeah,
That's why you put plus and minus. So there's an inflection point there at
so it's, yeah.
that. This is it's
And
not
then,
meant it's not meant to be confusing, but it is, because
then
you're go ahead.
oh, sorry, for the last, I was just gonna say for the last, for E, it's, so concave up would have like a positive slope, right?
It's wherever the derivative is increasing. So say the derivative is increasing here from 0 to B.
But isn't that positive slope?
Yes.
Okay,
Of the derivative.
right.
See, something's concave up on the original function if it holds water, or doesn't hold water. But the rule changes when you're looking at the derivative.
So why does it say the graph of F, but it's the graph of F prime really?
Because they're asking you to interpret the derivative and tell me something about the original function.
So do you look at the graph of F prime as if it's F? Because
You-
what's different about the graph of F prime and the graph of F then?
So if we're given the graph of f, you would have to visually like let's say I gave you this as your graph of f.
Mhm.
There's an inflection point right there and an inflection point right there, because you can see like that holds water, that does not, holds water, does not. But when
But how do you go from them giving you the graph of F prime and then knowing all that is like, do
so
you
that
just interpret it as if it's
yes, well,
F?
no, you know that because this is such a complicated
All the
thing.
answers are in F, like are,
Right, because they're going to always ask you about the derivative, or they're always going to ask you about the original function. Like it will always be the case that it's always about f when they give you f prime.
so you just use your answers for F prime as if it's F?
No.
But do you see like what I'm trying to say?
Well, you every calculus student has this confusion, because the rules are like different. Let me see if I can try to explain this. So this is the graph of x cubed, and the derivative is 3x squared. Let's see if I can get all three of these.
Yeah, 3x squared.
And then that the second derivative is 6x. Where is x cubed concave up? And the answer
Yeah, from 0.
0 to infinity.
Yeah,
Okay. Where is the second derivative positive?
0 to infinity.
Where is the first derivative increasing?
0 to infinity. Yeah.
So notice I ask you that those are all the same things. Where is this one increasing? Where is this one positive?
Mm-hmm.
And like if I give you this graph, you can tell me where the original function is concave up from the derivative. This is f prime, f double prime.
So they're all just the same answer, basically?
Well, it has to be. Like what I'm trying to get you to see or buy into, I think I'm really close, is that like if I give you like I just ask you the same question
Just in different ways.
different ways, and it
But it produces the same answer.
Yes, and it's supposed to. So now where is it concave down? You're going to say minus infinity
To
to
0.
0. Where is the derivative
Same.
decreasing? Same thing.
Infinity to 0, yeah.
Where is the second derivative negative?
Minus infinity to
Okay.
0. Okay.
Yeah.
I get it. So it's the
So,
same.
so notice that this point right here is a 0 there. And this is really a horizontal tangent. I haven't drawn it well, but it's there. It's that point there.
Mhm. Okay, that makes a lot more sense. So it's just different ways of asking. Okay.
Yes. All right, let me snip in question 3. This one is more straightforward because they just give you a polynomial. Okay, let f be defined by this function here. On which of the following intervals is the graph function both decreasing and concave up? So decreasing refers to the first derivative, concave up is the second derivative. So we're going to have to take 2 derivatives here. So take your first derivative, set it equal to 0, and then you want to factor that.
Okay.
Yep, and then get. And you definitely want to make a little sign chart here. Okay, let me know when you get it caught up to this point because I want to show you a small shortcut here, possibly.
Okay.
So when you often get a lot of quadratics, and you know that this quadratic right here opens up. So this quadratic has this shape to it, and that tells you the sign of the derivative. And we can test this, but it is positive, negative, and positive because of that. So well, let's test some points now to verify that. But you can actually just draw the curve over the sign chart and get like get the right values. So let's test like 5 over here in the derivative. So positive. This is positive. It's 3. This is positive. Right. Test 0 when you can. Positive, negative, positive.
So negative.
Negative, and then -2, negative, negative, and a positive makes positive. It coincides with that curve there. So we know it's only decreasing from -1 to 2. We still need the second derivative.
So
So
the second derivative is 12x minus 6. Yeah.
Yep. Set that equal to 0. You find that it's 0 at 2.
Yeah, 12x.
So it's good. It's good if you can line up the numbers as roughly as you can for this next part. So let's, and again, like you can use the same approach.
Wait,
12x.
12x. So it's 12x equals 6, and then you divide the 12.
Oh, I'm sorry. That's completely wrong. That's completely wrong what I did. There's 1/2. Okay.
Okay.
And the approach I just showed you does work. Like you can test points, but if you have any idea what 12x minus 6 looks like, the fact that it looks like that, it tells you that where it's positive and where it's negative. So could you confirm on your own here that this is positive when you test a value right of 1/2 and it's negative when you
Can I choose like an 2 or 1?
2, 1, yeah, and then over here 0 maybe.
Okay, so 12 minus 12 times 1 is 12 minus 6 is 6 positive, and then minus 1 is negative 12 minus, yeah.
This is why you want to get the numbers in the right place. So see how if I draw a dotted line here, and there's -1, we're looking for it's both decreasing and concave up. Okay, so it's decreasing from here to here in this window. Where is it concave up? Well, it's concave up also over here. So the answer is from 1/2 to 2. That's where they overlap. So the decreasing is from -1 to 2. That's why I like drawing them down. So you know, like, oh, it's in here, but then where is it also increasing?
You have to look at both at the same time.
Exactly.
Okay. Yeah, that one's much more straightforward.
Good. Okay, let's look at question 4. Yeah. Let f be twice differentiable functions. Selected values of f prime and f double prime are shown in the table above. Okay, so what you're supposed to interpret is when f prime is negative, that means the function is decreasing, and then it's increasing. The f is increasing and then decreasing. F double prime, if it's positive, it's concave up, concave down, and so on. But there's also, and I think what this is referring to is the second derivative test. Did you happen to
Yeah, we did
talk about that? Okay. Yeah, so when the derivative is equal to 0, there's a critical point here and here because it's equal to 0 at both of those places. We don't know what it is. It could be a min, max, or horizontal tangent.
Okay.
So there's the second derivative test that says f double prime of your critical point, if it's less than 0, it's a max. And if f double prime of your critical point is greater than 0, it's a min. It's backwards from what you might think, but that's what it is. So that information is enough to tell you what's going on at 2 and 8, because at 2, the second derivative is negative. That means it's there's a max at 2. So that's true. And then at 8, it's actually a min. So
like off what you think.
Yeah, exactly. And I don't know why, but that's I mean, I do know, but like that's not the point here. The point is like you got to know that rule. Sometimes they even tell you on the test or exam, like use the second derivative test, which is essentially taking the second derivative and evaluating your point to determine whether it's less than 0 or greater than 0.
Okay.
To give that answer.
Okay.
Okay. Keep going on here.
Yeah.
All right. Okay, the figure above shows the graph of the derivatives. That's very important. This is the derivative. It's not the original, it's the derivative. So you got to think like what happens when I'm given a derivative. You do care about zeros.
Yeah. Okay.
That is important. That refers back to the original function. Let's see what it's asking for. Has horizontal, they're telling you the horizontal tangents. We just found those negative. Oh, okay. I'm sorry. The horizontal tangents. So that's helpful for the second derivative, the horizontal tangents. So they're saying there's one there, and one there. Okay. There's also a vertical tangent there. Okay. Find all values of x for which f attains a relative maximum only. So I mentioned earlier.
What does that mean? Just find where the relative maximum is?
Well, from one of the very first problems we did, we said that if f prime of x goes from positive to negative, increasing, that's a max. And if f prime goes from negative to positive, that's a min. But if it's positive to positive or negative to negative, it's nothing.
Okay.
So we're essentially looking for crossing points. So these are the only two that like are of interest right there. So the derivative goes from positive to negative.
Yep.
So that's a max. Max at x equals -5. Justify your answer. The derivative, or you can just say f prime goes positive to negative.
Okay. And then -1, you're going
-1 is a min. It's not asking for that. But like you don't want to include that in your answer, but it's min at x equals -1. F prime goes negative to positive. But nothing else, no other points. So what they're trying to like they're trying to get you to like think somehow miss that this is the derivative and say that there's a max at like 2
Oh.
or something, like, I don't know, just like something else besides what's actually true.
Okay.
Yeah, so we actually answered question 6. It's the same graph here. Let me snip it in, and I'll just move some stuff down here. So this time it wants the relative
So
min.
we just did that.
We just did that, yeah. So it's
Okay.
it's the second part here, and then let's see what it asks for. Okay, so this is good. Question 7. We can answer this really quickly. Snip this in here. So same thing again, but it says find all values of x for which f double prime of x is less than 0. So f double prime of x is less than 0. That means it's concave down of f, but you don't have f, so that's not helpful. And if we go back to this example where I gave you these 3 graphs, it's concave down here, but what are we looking for in the derivative? How do you know if something's concave down from the derivative where it's decreasing?
Uh-huh.
So the question really should say, where is this function decrease? Where is the derivative decreasing? Like if it said, where is this decreasing? You would
-5 to -1.
no, decreasing, like going down.
Oh, so negative, yeah, 7 to.
Now there's kind of a weird thing happening here at, so from 2 to 3 it's decreasing, and so is it from 3 to 5, but that horizontal, that vertical tangent is not included.
Oh, that's so weird. Okay.
Yeah, it's excluded. So like, I think the thing that I would recommend you working on, I know you got lots going on, is really trying to understand this progression here. Like, what does this mean?
So
Concave
does
up.
7, can I see what 7 exactly asks again?
Yes, sorry for
So
f double prime of x
so
less
that
than,
just means where it's concave down or decreasing.
it's concave down of the original, but we don't have f.
So
Like
it's
that's what it's
asking me to
asking
find
for.
where it's decreasing then?
Yes. So the other way, it's basically asking, where's f prime of x decreasing?
Okay. Okay. Yeah, that progression is kind of weird, but it makes more sense now.
All right, great. So we got another lesson scheduled for tomorrow. Thanks so much for scheduling. I'll send you the notes out here in the next few minutes,
Okay.
and I'll see you next time.
Thank you so much. Bye.
Great night. Bye now.